in this particular question, what we've been asked to do is to calculate the volume of a given solution. Now, in this particular case, the solution is one of dissolved magnesium hydroxide, and in the question we've been given the mass of the magnesium hydroxide that's been dissolved. We've been provided with the concentration of the solution, and we've also been provided with the formula for magnesium hydroxide, and we've been asked to give our answer to 3 decimal places. So on first inspection, looking at this question, it becomes quite clear that some of the relevant equations would be the moles volume concentration equation, given what we've been asked to calculate is the volume. So I'm just going to quickly write that out. So that would be moles, and that would just put that in mole, and that's equal to the concentration times the volume, right? And so for the units for concentration, we know that's moles per dm³, and for volume, it would be dm³, right? Okay, so we know that this, because what we've been asked to work out is the volume, we know that this equation is relevant. But then the other thing in this, which because this particular equation necessitates us figuring out the moles, and we're not given the moles in the question, we're given the mass of the MgOH2. So another equation that becomes relevant specifically because of that would be the moles molar mass mass equation, which, if you recall, is moles is equal to the molar mass Okay, there is a better way I could have written this out, so I'm going to just switch this over. Because effectively what you're looking at when you're doing the moles and molar mass is you're looking at the mass divided by the so I mean I can write it this way, and I actually will write it this way. I will not make mass the subject specifically because of what we're actually aiming for, but conventionally, like, mass is equal to the moles times the molar mass, right? Or moles equals the mass divided by the molar mass. So in this case, moles would be equal to the mass in grams divided by the molar mass, right? Which would be in grams per mole. Right? Now that we have this, and we know that, okay, well, we need the moles for the concentration and volume equation, and from the mass and molar mass equation, we can figure out the moles because we've got the mass and we've got the formula. We can use the periodic table to work that out. Rather than working out the moles and then going to the other equation, what I'm gonna simply do at this time is eliminate moles from well, not exactly eliminate, but because moles are the same, so let's put it this way. The moles that are referred to in this equation is the same as the moles referred to in this equation. Therefore, we can equate this with this, and that's exactly what I'm going to do. So by doing that, we get a new formula, which is going to state that concentration times the volume is equal to, and it's going to be equal to this, right? So it's going to be equal to the mass divided by the molar mass, right? One other thing I'm going to do is, given the fact that what we've been asked to work out from the question is specifically the volume, I'm going to make volume the subject of the equation. Now, rather than writing out all of the units again, just for the sake of, in the interest of time, I'm going to do a bit of abbreviation, but, so I'm going to do volume, well, actually, well, yes, so volume, so vol, or just be like as vol, is equal to, and in order to get volume as a subject, what I'm going to do is divide both sides of this equation. So this side and this side, I'm going to divide both sides by concentration. So therefore the volume is going to be equal. And if we divide this side of the equation by concentration, it would be placed on the bottom half of the equation, because what we're effectively doing is multiplying mass over molar mass. We're going to multiply it by 1 over concentration, right? So volume is equal to, so just to visualize that, that's going to be like dividing that by the concentration, which obviously we know would give us 1, and we're dividing, effectively multiplying this by 1 over concentration. So we know that, okay, that's going to give us the volume is going to be equal to the mass divided by the molar mass. So you could just represent that as mR, right? So multiplied by the concentration. Right, so, but at the moment we don't have the numerical figure for what the molar mass is, right? So far we can, if we just do a quick audit of our question, again, what we see is we've got the mass, we've got the concentration. We don't have this yet, right? So we're going to work this out from the periodic table now. So MgOH2, right? I'm going to assume that you know the formula for working out the molar mass. So that's, we're going to add up the relative atomic masses of each element present multiplied by the number of times the element appears. So the multiplied, so effectively, if you look at these excerpts from the periodic table, we've got, what we're working out is Mg, and then we've got OH2. So as I said, for each of the elements we've got to get the relative atomic mass. So in this case 24.3 for magnesium, right? So 24.3, and that appears once, right? So we've got just 1, and then we're gonna add this to the, so for OH is 16, I'm just going to put this in brackets, so 16 plus 1 from the hydrogen, so plus 1, and that's going to have to be multiplied by 2, right, because it's OH2. So when we work that out, the number you should come up with from your calculator is 58.3, okay, so equals 58.3. So that's the molar mass in this case. The molar mass is 58.3. So I'm now, if we now refer back here, right, I'm just going to put a placeholder just here, just to say MR, so that we don't have to go back over there again. So put MR equals 58.3. Effectively, if we look back at this equation and we do that quick audit again, we see, okay, yes, we've got all of these values now. So it's quite straightforward from this point. It's more just plugging in the numbers we've got, right? So when I'm writing this out now, for the purpose of precision, I am going to include the units, right, along with the numbers. So the volume is here is going to be 44.133. I'll write the units in a different color for clarity purposes. Grams and we're going to divide that by the MR, so that's 58.3, right? 58.3, and the units of that are going to be, as you can see here, it's grams per mole, right? And then we're going to have to multiply this by the concentration. As we can see, we are given the concentration in the question as well, so this is 1.044. 1.044, and the units of that, as you can see, it's given as well, moles per dm cubed. Moles per dm cubed. Okay, so one of the other things here in this question is, if you, well, at this stage, I would, before I move on, at this stage I would invite you to work out what this is on your calculator, and well, if you do that, what you should come up with is 0.72509,414, right? So that is effectively the first value you've got out when we're trying to work out what our volume is, but we do need to adhere to what the question has asked us to do. The question has specifically said, give your answer to 3 decimal places, right? So therefore we have to, that's going to be equal to 0.725, and now for our units. Now there's 2 ways to approach the units. One, I would just suggest is, well, from a knowledge angle, you kind of know, well, in the case of a volume, what's the volume going to be measured in? We've already got it here, it's in dm cubed. So that's one of the approaches. Okay, 0.725 dm cubed, okay? However, for the purpose of like a sanity check, I would say it can be useful to work out the units specifically from the question, which is part of why I just made a bit of a distinction of the units in different colors. So if we just look at this and write this out, just the units, we've got grams divided by, and then I'm going to put each of these in brackets. Okay, so grams, moles to the -1 multiplied by moles multiplied by dm to the -3. Okay, so if we now process those units and see what we come up with purely on the units basis from our question, and before I go on, I'm going to explain why this can be valuable. In some cases, let's say we're working with other units like centimeters cubed, other things like that in our question, by doing this sanity check, you can try to make sure that actually, okay, does our answer actually match the units we're using in the question? Does the proportionality match? In this case, there was a need for volume, for unit conversion for the volume. But anyway, if you go ahead, mole to the -1 multiplied by moles, that cancels out. Right, now we've got grams divided by grams, that cancels out, right? And what we're left with is dm to the power of -3 and well, 1 divided by that. Now if we actually write this out in full according to what we actually have remaining here, because obviously grams divided by grams, you're just going to get the 1 at the end. But what we've effectively got here is 1 over dm to the minus 3. Now what is dm to the minus 3? dm to the minus 3 is 1 over dm to the 3, right? But we've got 1 over dm to the minus 3. So therefore that is equal to 1 over dm cubed. Which is what? Which is, well, we have to multiply this by this, right? Which gives us dm cubed over 1, which is, of course, is just dm cubed, right? So on the basis of that, we know that our units, even as we approached it from a purely units-based derivation kind of perspective, like what do we get if we just use what units we started with in the question? Again, we just come to dm cubed. So we've looked at it from 2 different perspectives and we've come to the same units. So okay, so this would be our answer. 0.725 dm cubed would be the volume of our solution of MgOH2.